Let's take a look at this question. Two individuals mate and produce offspring. The genotype for individual 1 is what you can see there, that combination of alleles. And the genotype for individual 2 is that second combination of alleles that you're able to see here. How many genetically different gametes can each individual make? All right, well, we know how to approach this question based on the problem that we did earlier. The key here is to look at the number of heterozygote allele pairs at the same loci. So we've got 1 for the A's, the B's are homozygous, the C's are heterozygotes, the D is homozygous, and the E is that heterozygous condition. So we're going to have 2 to the third, which is going to create 8 genetically distinct gametes. Now for individual 2, if we do the same thing, we've got 1, 2, 3, 4. So we've got 2 to the 4, which is going to create 16 individuals. Now let's take a look at section B. What is the probability that one of their offsprings will have the genotype specified here on the screen? Well, in order to approach this question, you have to understand a little bit of probability. Whenever you see a question that's looking at these chance events or this probability, the best way to approach it is to just break it down by what are the probabilities of each individual passing down a certain allele. So I'm going to delete here my markings just so that you can see these original genotypes better. And so when we look at individual 1, and let's look at each single trait individually. So let's start with trait A for individual 1. What is the probability that individual A is going to pass on big A to its offspring? Now it only has 2 shots. It can either pass on big A or little a. So we know that that probability is going to be a half. Now if we look at what is the probability of individual 2 of passing on that big A, it's also a half. So now that we know the probabilities of passing a big A for individual 1 and individual 2, we can say that the probability of the offspring to get big A, as is asked for in this question, is 1/2 times a half. So the probability of big A is 1/4. All right, now we can do that for the rest of the combinations here. So what about for the trait B's? What is the probability? We're interested in the offspring having 2 little b's, that individual 1 will pass on a little b. Well, that is 1. That individual 1 can only pass on a little b. What about individual 2? Individual 2, if we're interested just in the little b, can pass a little b half of the time. And so the probability of little b is going to be 1/2. Now for C's, we're interested in the probability of the offspring and having big C. That is going to be 1/2 from individual 1 and 1 from individual 2. So the probability of big C is going to be a half. Now we can look at the D's, and we are interested in getting 2 D's for this offspring. The probability of getting D's from individual 1, a big D is a 1, and the probability of getting a big D from individual 2 is a half. So we know that the probability of getting big D is 1/2. Now what about the E? We're interested in the offspring getting 2 E's, 2 little e's. So the probability of individual 1 passing on a little e is a half. The probability of individual 2 passing on a little e is a half. And if we multiply those together, we know that the probability of little e is 1/4. Now we've got all of these fractions here, so what do we do with them? Now we can look at what is the probability of getting each of these pairings that we have just calculated to occur, because that is the ones that we are interested in given the problem set. So the probability of having that offspring with that particular genotype is the probability of getting AA, which is 1/4, times the probability of getting little b, which is 1/2, times the probability of getting big C, which is 1/2, times the probability of getting big D, which is 1/2, times the probability of getting little e, which is 1/4. And so the probability is actually 1/128. Okay? So that is how we can figure out what the probability is of a particular offspring getting that genotype.